Hello YouTube viewers, welcome to my show Science Thursday. In today's episode, we're going to talk about how to generate electricity from wastewater. So let's dive right into it. Now, first thing you have to understand, wastewater treatment, if you have checked my last whole playlist and whole series, you must have understand it's very complex and it's very intensive. As in, the only process of making bad water into safe water, not potable water, not drinking water, just safe water, basically something that you can safely discharge into rivers and ponds and not kill all the aqua life there, is just very, very intensive. And primary energy draw in all these plants, whatever sewage treatment plant you have, is generally from pumping. Basically, you have air pumps, you have water pumps, and you have to understand water pumps that are in your home and doing your local thing, they're not very big. They don't have to be, because the water there is clean. But when you're talking about sludge and slurry, it's like basically using a pump to pump ketchup, and that's when you're lucky. Sometimes it's like pushing upwards of something very thick, so it takes a lot of electrical mechanical power to actually do the pumping. So pumping is very, very serious power draw. So basically they might have power draw of, like, let's say 2 megawatt. Almost most of them would be just pumping, air pumps and water pumps. And overall, this translates into a ludicrously high running cost. So this running cost becomes an issue that many small communities simply will not have a sewage treatment, because even if, let's say, some billionaire gifted them, it's like, okay, here's the money, here's the plant, build it and enjoy. Awesome. At first few days they will do it. It's just once the electrical bill will come, is, yeah, let's just close the door, let's not think about it. So to make sure that that issue does not happen, that you built a plant and you are not using it simply because of electrical bill, we want to make electricity out of the plant. So again, how the heck you can make electricity out of wastewater? You have to understand water has no energy. Because water is the burnt state. Basically, if you take oxygen and hydrogen, you burn it, you are burning basically rocket fuel. But once you have burnt it, like the process is done, you get water. It's like carbon dioxide. You can't burn carbon dioxide. Same way you can't burn water. Now, so where the power is coming from for you to extract it? First source is biosolids, basically human feces and animal feces and all sort of biological things, all of them combined, and they allow a very rich biosolid material. Especially if you have agricultural waste and like a meat industry and all that, they dump tons of biosolids, like tons. And if you have a restaurant and all that, they dump so much grease there that's like a rocket fuel flat out. So that's the power source. It's not water that is power source, it's just the biosolids they are adding on it. On top of that, there is electrical chemical potential there, that's coming from chemical energy. That is like your soap, that is like your urine. If you hear people say like you can use urine to create electricity, it's scientifically possible. It's just, it's not rocket fuel, it's not too powerful. Basically, think of it this way: your body consumes a fuel, whatever it is, like alcohol, milk, whatever, it's a fuel you are consuming it. The waste fuel, that is like basically once you have burnt it and your body has metabolized it, the output, urine, still has some energy in it. Not too much. Don't expect it like, pee into basically your rocket engine and take it to space. It does not have that much power. It does not even have enough power to run your car, but it has there. So that is also a very rich source of basically electrochemical energy right there in your wastewater. So these are the source of energy. So how do we tap it? Now first, the simplest, the easiest way to tap it, anaerobic digestion. What does that mean? Simply you let the biomaterial rot without oxygen. So once they rot without the oxygen, they will create methane. Now once you have doing the rotting, quote unquote, all that's happening is like big chunky materials are breaking down into smaller ones. Now this is happening on a chemical level. So basically you have big things and it's being broken down to smaller things. Now the bacteria that does this generally gives out an output. That output is methane, CH4. Now here's the funny thing about methane: it's produced no matter what you do. So you have to understand one aspect of methane, that methane makes CO2 look like a baby throwing tantrum. So if you think few billion ton of carbon dioxide is going to harm your planet, just remove few zero of it, basically 20% lower than that, 20 times lower than that, that is the amount of CH4 you need to like basically blow up the planet. So you have to understand methane is ludicrously potent and it's long last. CO2 breaks over time, but methane lasts for a very long time. So methane is ludicrously potent as a greenhouse gas, so we have to burn it. Like, it's much more efficient to burn it than to like just let it go, so you have to use it. So we take it, and thankfully, even though it's very hard to store in terms of you can't just store it volumetrically efficiently. It's not a liquid fuel, and it's not propane or butane where you can compress it efficiently. So that's why the tank that can quote unquote liquefy CH4, that's very expensive. So we generally store it volumetrically, basically just build a very big tank, as big as you can build it. But it also gives you fertilizer, because once you have broke down those basically microbial life have done its deed, it has broken down many big complex things into smaller things. Now those smaller things a plant can easily digest. That's the whole point of a fertilizer. It helps plant to digest it properly, because plant can take care of itself. But if it has to think of it this way, like your mouth spends energy to chew the food, but it must be below the certain limit, otherwise you won't have the enough energy to like chew the food itself. Basically you take 100 watt, your mouth should spend, let's say, 80 watts bare minimum maximum. But if like your mouth is consuming 120 watt, you simply won't have enough energy. So input and output has to be maintained. Fertilizer helps that. So the fact that microbial life have already done it, because they broke down the thing, and now you got CH4 as a basically energy output, you can directly run almost any generator into it, and then you have fertilizer. It's a win-win scenario. Then many plants already tried this, but it failed. The reason why it failed is simply because you need a lot of space for this. So biodigester, you want a dedicated plant for it. So somebody came up with the very ingenious idea, is basically create a multi-plant to dedicated plant system. So you will have, let's say, a big city like New York or Delhi or Mumbai, they will have multiple sewage treatment, sometimes hundreds of sewage treatment plant. So what they will do is, like, their biomaterial collection department, they will be like, okay, just collect the biomaterial, don't try to filter it, don't do anything extra into it, just remove the water from it as much as you can do, and then send the sludge to one dedicated plant. So that dedicated plant is like now dedicated to do one thing and one thing well. It makes it into biogas and creates a very good quality of fertilizer. So it's became very ubiquitous. Many plants are doing it, and energy generation is serious. Like, it's not like, oh, enough energy is just created just so you can run your plant. No, let's say plant energy consumption was, let's say, 5 megawatt, it was producing 6 megawatt, so you can sell 1 megawatt. So that's net profit. So that also reduces your operating cost, and it's simple and easy. So inherently there is nothing magical about this technology. It's not like, you need some scientist to like sitting there like maintaining hundreds of things. It's not a nuclear reactor. It's a simple thing. So that's one way of converting sewage into electricity. Second way is microbial fuel cell. Recently you must have heard basically Bill Gates have a lot of moonshot projects where it's like, it's a big gamble. If it works, it's awesome. If it doesn't work, well, you wasted the money. That's why the moonshot. If it works, it will change the world. One of them, some persons showed the idea of using urine as a fuel source for a generator. How the heck that can happen? One very simple reason. I told you, like, your body has already metabolized the whatever you took input, but the output, basically the urine, it still has some energy left. Not too much. Don't expect like a rocket fuel, but it has enough. That can be converted using microbial fuel cell. Basically, you have three primary types of fuel cell. One, hydrogen-based fuel cell, old technology, we have been using it for hundreds of years. Then you have second type, hydrocarbon fuel cell. Bit expensive, bit tricky, but we are trying to create it. You can buy it right now, and it can be used in biodigester plant directly also, because it runs on methane, and methane is the best fuel for it. You can run it till LPG, basically till propane it can use, but you can't put diesel into it. So you can use that. And in this scenario, basically there is nothing mechanical happening. There is no electrical physics is not acting here. Basically, it's some bacteria have the property of giving electron when they do their digestion. So using that electron, we are creating a circuit. That free electron is creating the circuit. So it's basically like a fuel cell, but the active medium is the sewage, and the reactant, basically whatever is the acting part, that it's a bio life form. It's a live cell. So don't understand, like, you can't put UV light inside this, it will kill it. So you have to understand, it's a very promising technology, because it simply takes a electrochemical potential. Basically, if you are urinating in the water, there is a chemical imbalance there. That imbalance can be converted into electricity. Not too much, but enough. And it's simple and direct, because you simply have a sewage plant and you just have electrode in it. Nothing fancy, it's simple. You don't need a custom plant built for it. However, it is still in lab stage. Like, of course, this technology is old, as in like in early 1900s somebody figured it out, but nobody figured it out how the heck that's happening. Like, it's happening. Why it's happening, we didn't understand it. And I have provided a 40-minute video down below. You can see it. Like, it's a very complex thing. It does work. You can buy it in case of like a lab experiment and all that, but it is not something that like, okay, just give me this plant, this much handling capacity. It's not there, but it does have a tremendous potential. So this is also one way. Some plants, like it's not like a no plant exists in the world that utilizes this technology, but some plants do. So this is one way of using electrochemical energy, not the biomatter, electrochemical. And of course biomatter also helps, because some bacteria work in what we call symbiotic relationship. So there is this is a very complex topic, so please watch that 50-minute video. Then we come to the fact, if these are complex, even biodigester require you to build an independent plant to get the most out of it. Why the hell bother with this thing? Well, you have to understand that money matters. At the end, money matters. Nothing else matters more than money. So how do we manage money? Yeah, I told you specified. Let's say you are a town, you are New York, and you are like, let's build sewage treatment plant. Awesome. You got the money, you did that. But the moment the running cost will come to you, you will be like surprised and shocked how much it is. Because you have to understand, when you are talking about running a plant, you have multiple other things. First, you have to worry about the infrastructure, basically electricity, water, all that. Okay, first infrastructure you have to worry about. Then you have to worry about the equipment. Basically the equipment is not eternal. It's gonna break down, it's gonna require its own maintenance, so you must have backup equipments. This is a city level equipment, so you cannot have like, okay, just one. You will have three, and one of them should be enough to keep the whole system running. You will keep like one on, another off, one off, on off, one year, and third one will be just raw backup. So those also add up the cost. Then you are talking about person, whatever you are person, you have to keep that, and that person have to be educated. It cannot be minimum wage worker. The person has to know how pH works, how nitrogen works, how all those things work. It is a very skilled demanding job, so you have to be a skilled worker. Those are expensive. On top of that, once you have taken care of all this, you have to worry about the electrical bill, which is significant. You have to understand, whole United States electrical production, 2 to 3% goes into just this wastewater cleaning, and that's a lot of electrical energy and lot of money. Doing this makes it self-contained. Now the self-contained aspect is the interesting part. That means you can build it in a rural area and just have a small power delivery system there, just in case, like let's say power fell down and all that. You don't need a power plant. Okay, it has to be close to a power plant, it's consuming megawatts, or it has to have like 11 kV line or 33 kV line or 135 kV line, so it can keep running. All those things might make it more financially viable, that we can actually clean our own water. So that is a very, well, I will say, noble system. And given the fact that you get fertilizer as a byproduct, that's also a monetary incentive. So that is why we want to do this. So many old plants are now being shut down and they're being rebuilt with biodigester or that fuel cell. Fuel cell I have only come across like one or two, but let's see how it unfolds. So this was my presentation on how to make sewage into electricity. I hope you liked it, learn from it. In that case, please leave a like. If you didn't like it, don't worry about it. You can press dislike. I would urge you to press it twice to show me your extra disappointment. And please leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.